on the flip side, if somebody bothers enough to listen to a machine learning podcast and stay through till the end, so maybe they should get the benefit of knowing the question ahead of time.
If they sat through this, then you know what? Just let me know. Let me know you heard it. I'll let you.
It's a little bit of a discount for sitting through the podcast. All right,
exactly.
Hello and welcome to Infinite Machine Learning. This is your host, Prateek Joshi. In each episode of this podcast, we talk to an amazing machine learning practitioner and dive deep into a specific topic. We have Shaabana on the show today. He's the co-founder of Bittensor. It's an open source protocol that powers a decentralized machine learning network. He has a PhD in computer science and has previously held roles at Instacart and VMware. In today's episode, we cover a range of topics, including what are the shortcomings of centralized AI, how to decentralize AI research, what are incentivized computer networks, what they're building at Bittensor, how to put AI on the blockchain, and decentralized governance. This is a brilliant episode, and it's just packed with so much knowledge. I'm really excited for this one. So, ready for liftoff? And 3, and 2, and 1. Let's go. Ala, thank you so much for joining me today.
No problem. Thank you for having me.
No, you're the co-founder of Bittensor, and your goal is to put AI on the blockchain. I know there are more details to it, but before we talk about Bittensor, can you talk about the shortcomings of centralized AI, meaning why even bother decentralizing it?
Right. Yeah, it's a very, very fair question. So to give you a bit of fair background, myself and my co-founder, Jacob Steves, we're both AI folks. We came from AI backgrounds. I'm coming from academia, did a PhD in applied AI in 2017. My partner, Jacob, comes from Google. He worked on quite a few AI projects over there as well. And together, I guess together and separately, we found there's kind of 3 inherent issues currently in AI today, right? The first part is that AI today is inherently non-compounding. So there's research being performed on AI every single year with these top conferences, and especially since 2011 with the release of the AlexNet, the amount of compute and research that has been applied to AI has been really exponentially skyrocketing since then. What's happening is, researchers will take a paper, they will, tinker with it, they'll understand how it works, and then they will add something to make it better, get better performance, squeeze every last percentage of that performance, and then publish that, and so on, giving us great strides in how AI has gotten and how smarter we've gotten with the programs that we're building. Now, the one issue with that is the research itself, the human base of knowledge itself is compounding. We are building on top of what we've learned, but AI itself isn't. We're always training from scratch, right? Now, let's say that, Prateek, let's say you've got the latest and greatest GPT-3, you're OpenAI, you've created something that's really awesome, and I want to beat you. I want to create something stronger or more powerful. I can't use what your model knows. That knowledge is not shared. Your model's siloed completely. So what I need to do is I need to start from scratch, effectively relearn everything your model has learned, and beat it with whatever percentage score that I've got that's higher than yours. This is inherently rather inefficient. It's rather wasteful, and you don't really end up with quite the same amount of knowledge that you come out of it as you should. The second issue with AI that we found is that as it stands today, as a researcher, if I really want to tap into some powerful compute or some powerful resources in AI, I need to really be working at either a big company or I need to be working at an academic institution with a lot of funding, right? Let's say if it's just me right now, I've got a little computer here with 2 graphics cards, I'm not going to compete with the big guys, right? But I still want to have access to that quality of knowledge that I can train from, right? There needs to be some kind of place to do that. Now, in a lot of ways with AI, we are living in the 1970s, right? We've got these big mainframes. We need to be working at the big companies to deal with the mainframes and use them then. And then kind of right after that, during the 80s, the internet kind of was introduced, and then it exploded in the 90s and 2000s. And now, instead of these big computers, we have these many, many smaller computers that are all connected together. We believe we are at the same nexus point with AI. We're about to kind of hit a point where it's no longer the big computers that are kind of operating everything, but we're kind of going to have a bunch of little computers that operate together interconnectedly. And we argue that, if you take the idea of, for example, Bitcoin, right? So Bitcoin is this essentially a gigantic decentralized computer. Now, I believe there was a census in the mid 2010s. I think it was 2016, 2015. They had said that at that point, Bitcoin, the full-on Bitcoin network, is larger than 500 of the world's supercomputers combined in power. And all it's really doing is guessing hashes. It's just guessing random numbers. It's not really doing anything useful. What if it was doing something useful? What if we applied all this compute towards AI? Imagine how far we're going to get. So that's kind of the second argument that we came up with, is that what if we kind of decentralized it and we kind of got the same power as Bitcoin at one point in the future, and we applied all of that, right? And finally, this point is a little bit more political, I think, but we don't believe that AI itself can be achieved, or the holy grail of AI, which everyone talks about, is AGI. We don't think it's achieved by like one company or one lab in a university. It's going to take everyone's ingenuity, everyone's talents, everyone's intelligence to kind of put together. We're not even at the stage of understanding what the heck AGI is going to be. I'm not saying we're going to achieve it. All I'm saying is, if you want to achieve the state of the art, it's similar to how we landed on the moon, right? It wasn't just NASA. It was a bunch of different organizations that got together and put this all together.
Right. That's actually a really good point. The entire Bitcoin network is just busy guessing random numbers, which is like, I know the reason they're doing it is to mine, but is it useful to humans and in the bigger sense of the word? Probably not. It's just like you'll mine and then you keep doing that. So okay, so now you talked about AI research, and with Bittensor, you want to decentralize AI research and reward labs for building better models. So first, can you tell us what you're building at Bittensor, and also how does it work in practice?
Yeah, absolutely. So effectively, kind of the simplest way I could put it down at Bittensor is, I think you mentioned to me earlier that the audience has some AI knowledge background. So it should be fairly straightforward for me to mention that we're basically building a decentralized mixture of experts. So for those who aren't familiar, mixture of experts is really just a way to kind of expand the capacity of a model without affecting compute as much. So what you end up having is a model that contains several submodels within it. And what happens is that model will intelligently pick, it's effectively conditional computation within neural networks, intelligently pick which model to route the input to, which expert to route the input to, that's able to kind of effectively perform the right computation on it and kind of get the right result. Now, at Bittensor, what we've done is, Jacob and I met at this a nonprofit collaboration called For AI, and what effectively we had been kind of working on is kind of a decentralized mixture of experts without the blockchain. So what we found is that it was possible to actually have several models living on several different computers and have them kind of train together. They kind of exchange information back and forth, and they're able to kind of train with each other at the same time. So they're kind of, let's say you have a model, I've got one as well. We find that we're both working on the same modality, that is text, for example. And what would happen is I would learn from yours, and yours can learn from mine. Now, the problem with that, and that approach has been, the idea of decentralized, XYZ based on altruism, which is no real incentive, has been done before. Right, you've got SETI at home, the Search for Extraterrestrial Intelligence. You've got Folding at Home, which is another project. They're great, but there's two problems with those, right? The one issue is that every computer was solving the same problem. So really, it was a competition between who can solve the problem first. And second, there was no incentive. I just really did it out of either interest in the project or the goodness of my heart, but that's it. Now, in Bittensor, we found that if you incentivize folks, and everyone's working on a different problem, so your model can be maybe doing text generation, mine could be doing text analysis. There can still be something that we can kind of work with together in that sense to kind of learn from each other as we go and kind of, in a sense, reward the more useful models on the network.
Yeah, you actually mentioned a really good point about incentives, because I strongly believe that incentives drive everything. Like, I know altruism, it's nice to think about it, but that's not how markets work. Like, I think it was Charlie Munger who famously said, like, show me the incentives and I'll show you where it's going. Like, basically, like, you can exactly tell what people are going to do based on how you incentivize them. Okay, so let's talk about a network of computers, but they're incentivized. So can you describe what the incentive structure is? And also, when it comes to a decentralized network like this, what are the characteristics of a good network? Like, ideally, what do you want to see in that network?
Right. That's a really good question. Before I proceed a little bit further, I just want to give a bit of insight. The way that we're set up, like basically from this point onwards, just think of it this way, is that there's two layers to Bittensor. There's a blockchain layer, and then there's the actual network layer, which is the machine learning bit. I'm going to be speaking exclusively about the machine learning bit, and then I'll move on to the blockchain layer a little bit after, just kind of make it a little bit easier to kind of digest. Now, and the network itself, what's happening is you have many nodes, all of them solving, every node is one, you can think of it as one neural network model. We call them neurons, not to be confused with the actual traditional neurons. And then each neuron contains effectively one neural network. And this neural network could be solving any problem as long as the rest of the network is on the same modality. So right now, Bittensor is only focused on text until we can actually figure out and fully solve the problem for text. We're not going to move on to other modalities yet. So your model could be working on text, for example, on its own problem. It could be a GPT. It could be, it could be an XLM. It could be, whatever you need it to be. And what this model is going to do is the first thing as it joins the network is it's going to use the Bittensor API to communicate with the blockchain to kind of understand who's the highest ranking model in the network right now, right? Who's the best performer? Now, we measure this performance using several mathematical concepts, which I think are too detailed to jump into in this podcast, but what is effectively Fisher's information matrix. We're kind of just measure the significance of a neuron to its peers, right? How much worse would the peers' loss functions do if this neuron was removed, really, is the question we're trying to answer when we rank these peers. So what it does is it tries to find the highest ranking peer and then talk to it. And then see if this peer is actually something that's useful or not. If it's not useful, it's going to move on to maybe a different peer that's more useful as a result, and so on and so forth. And then what happens is in the network is as it's speaking to these peers and as they're being useful, what your model is going to do is it's going to rank them as well according to its own significance, according to its own use case, right? So this means that the ranking is a little bit relative, and we do a lot of work on our network to kind of make sure that these relative rankings eventually become a collective understanding on the blockchain. Basically, what is effectively called the consensus of who is the best performing peer to everybody else on the network. Now, as this model kind of learns from other peers, it's going to rank them highly. And at the same time, you have the option of either becoming a producer or consumer or both. So what you can do is you can either just consume, really just learn from models, not rank them, have nothing to do with the model, with other models, and have nobody ping you back as a result or learn from you. You really just learn. You can be a producer, which means you just teach, we just help other models out, and then you get rewarded as a result. And you can be both, meaning you can either train and infer basically on the network at the same time. And then effectively, once your model has learned and once it's actually been ranked and has ranked others, then it's able to receive a reward as a result. And the reward is basically corresponding to how useful it has been to others in the network itself.
Yeah. No, I think that's really good to understand how it works. You mentioned, or at least I think it's mentioned on the side, that the Bittensor network is comprised of 4,096 miners. Now, before we dive into the specifics, can you explain to the audience what a miner is?
Absolutely. Yeah, it's a really good question. So you can think of the Bittensor network, actually, there's two types of nodes you can have. You can have a validator or a miner, right? Now, miners will hold a neural network. It could be your own. It really could be anything. The way we design the Bittensor network is it's really an API. So you can bring technically any PyTorch-based network will be compatible with the Bittensor network, and it'll work right off the bat. And now, as a miner, what you're doing is you are training your model, and you are helping others learn from you as a result. So people can infer from you, and you can actually fine-tune your model that you have, for example, by speaking to others. And others will rank you accordingly. That's effectively what a miner is. It's just a model that's deployed on the network, and it's kind of inferring and training at the same time. Now, your validator really is the kind of the how do I say this? The meat of the pie, really. It's basically what keeps everyone else honest, right? So without validators, there's nothing stopping me, for example, from deploying 1,000 nodes, and they're all just ranking each other highly and saying they're all really good, and then getting all of the reward as a result, right? That's collusion. It's passive collusion, and that's a really big problem. So validators, what they do is they ensure that everyone on the network is a real model. It's not just some random program spewing up random garbage back data and kind of getting rewarded for it. And at the same time, they also ensure that the consensus is reached, that everyone in the model is actually ranking others as well as themselves correctly, and not kind of going crazy with the ranking in an illegal way, so to speak.
Right. So let's talk about that a little bit, because that was one of the things I was thinking of is, let's say that's 4,096. Let's say I have a lot of resources, and let's say I'm somebody with bad intent. So can I just take over more and more of this network? Because I'm doing the work. I'm spinning off one miner, and then I'm going to do another one, and I keep doing that. And eventually I'll get to own maybe 1,000 independent miners. Then I'll start colluding. So how how do you detect collusion? That's one. And two, what I'm doing is not technically illegal because I'm spinning off independent miners. I just happen to own them through a bunch of entities. So how do you work through that?
Yeah, so we describe it as a sophisticated attack, right? You appear normal, you appear honest when you first join, and then when you take up more and more of the network, then you start kind of becoming evil, really, and kind of ranking yourself that way. Yeah, to be honest with you, at this point in time, it's very difficult it's too expensive to even do that. The first step, for example, right? Like this 4096, and that's capped on purpose, right? We have a lot more competing miners that are trying to get in. We don't really have numbers on that, but the competition is rather high. And so for you to be able to actually join the network in the first place, there's a proof of work mechanism you have to do, which basically is you're saying that you have the compute to do this, right? And frankly, with the best graphics cards, we're finding that it's taking about 3 days to join. So it take a while to take over the network. And it's too expensive for you to even do that. But for the sake of argument, let's say that it is very low. You can kind of join, you can try it out basically to kind of stop that. Now, if you get past that bit, which is really kind of a Sybil attack, what you've done, and that's why we have the proof of work mechanism to stop this kind of Sybil attack. The other miners in the network, putting aside the validators, the other miners themselves are also able to see that you're not ranking them. The miners that are joining newly, they're not ranking other miners in the network. They're just ranking themselves. That in itself kind of creates a bit of a disconnected graph in the network. And what happens is those honest networks, all honest nodes in the network they're going to stop ranking you as well because you stop ranking them. So even a bad ranking is a ranking, but if you stop ranking people at all, then you've effectively stopped participating. And if that happens and they kind of stop ranking you, you start losing. And as you lose rank and as you lose influence, you get kicked out of the nodes eventually. To kind of do that, you have to literally buy out all 4096 slots at the same time. Insane.
Yeah. And also I saw the specs of what it takes for each node. And yeah, it's not trivial, like 100 gigs, there's NVIDIA GPU and a bunch of, somebody if they really want to do it, they probably can, but it's going to take a heck of a lot of money and patience to do that.
You'll need to basically be the Google to kind of be like, hey, I'm going to take this whole network down, whatever. That's how you do it. But yeah.
Right. Okay, great. So let's assume that that's an edge case. Let's assume for now that it's not the main problem. Okay, so we have this group of nodes. Hopefully, each node is run by a person or maybe a lab. You also mentioned that there's a mechanism where the least performing node is kicked out and a new node comes in. So can you explain how that works?
Yeah, absolutely. So the least performing node gets kicked out. Let's say we start from node 0. So let's say it's like node number 4095, right? That's the one that gets kicked out. Now, the least performing node is either a node that is not contributing any insightful knowledge from the neural network. So maybe it's junk, or the neural network's too small, or it's just not competitive enough. Or it's a node that is not holding a lot of stake. So, for example, if you have a really bad network, but you have some stake with you, you can still validate. So there's a limit where effectively after a specific amount of tau, you become what is effectively a validator. So you can still participate a little bit. But if you got low stake and your model's not doing very well, what happens is the next person who tries to register and they get through the registration process, they get to kick you out. And that person, when they join, they get to have an immunity period where their neural network is ramping up. It's finding other nodes in the network. It's kind of like starting to contribute and starting to get ranked. It cannot get kicked out in that time. So what happens is the next worst performing node gets kicked out as a result, and so on. So it's kind of just giving somebody a chance to join the network and be competitive, really.
Right. During, let's say, the least performing node, they're part of the network. They earned some rewards. Do they get to keep that, or how does that? Like when they get kicked out, can they come back? Do they get to keep the reward? How does that?
Their
work?
stake is whatever tau they earned is returned back to them. Basically, it doesn't. We don't take away their tau. The network is only additive; it's never subtractive. So if you earn any tau and you get kicked out, that tau is just returned to you to your wallet.
Got it. Oh, briefly, can you explain tau for our listeners?
Yeah, absolutely. So tau is effectively our incentive mechanism. It's the way that we incentivize miners and people to join and to contribute, whether it's compute or it's a neural network or whatever it is that you kind of help out with, you get rewarded with tau, which is our cryptocurrency as a result. Now, seeing as the entire team is really AI engineers, we're not crypto developers that are doing AI. We're AI developers that are using crypto to solve a problem. So tau itself was launched as a fair launch. So there was no pre-mine or ICO or some crazy amount of tau that's issued. We're following the Bitcoin curve. So that means there's only there's only going to be ever 21 million tau. And the only way to obtain tau right now is to mine it. You can't buy it anywhere. You can't sell it anywhere, really. And you can't really do much with it unless you had mined it, really.
Got it. So today, can I exchange it for any other asset?
There are some over-the-counter Discord channels that do this. We're not involved in those because from a legal ruling and everything like that, we want to kind of stay away. We are working on a decentralized exchange, so we're going to plug into the Polkadot network. And which Polkadot network really is, for those who don't know, is effectively it's a blockchain of blockchains. So we can block in our blockchain that way, and then we can exchange our TAO for dots. Dots are publicly traded. You can basically, if you exchange your TAO for dots, and then you can sell dots anywhere you want to, and you're good to go.
Got it. Yeah. I think that's pretty much, that was my question, is because let's say hypothetically I'm also on OpenSea and I see this NFT and hey, I want to buy it, but I earned this TAO, but it's not usable. So it looks like it can be exchanged for an asset, and there's a mechanism for that. Okay, great.
By end of the year, that's right, Q4.
Yeah, I mean, it's in the future. It's not, yeah, okay, perfect. So we talked about that. Now, you also mentioned early on that millions of GPUs right now are being used 24/7 to keep the Bitcoin ecosystem going, right? There's a lot of energy consumption. And I think in your literature, you mentioned, let's say we want to take all of that and direct it towards something meaningful. So on a conceptual level, before you started, like, how did you envision, like, what does a new kind of blockchain look like, especially in the AI context? And also, in terms of energy consumption, is there anything on that front we need to think of?
Yeah, so there's kind of a few facets to that question, right? It just really depends on how you approach it. So we can't really compare ourselves as AI engineers about the energy that we're spending on training to the blockchain, like for example to Bitcoin and what their energy consumptions are, just because theirs will likely be much larger just because there's so many more computers. And just generally proof of work algorithms are much harsher on the GPU than a regular inference or regular training. So, as a kind of a bit of an example, proof of work, if you just run any proof of work system on your GPU, you're just going to see like the load just stay high. It's never going to go low, basically. So it burns the hell out of it. Whereas if you've got your inference or your training, you can kind of see like this almost sine wave in terms of how it works. Now, generally speaking, when we're talking about Bitcoin, right? Let's just talk about Bitcoin specifically for now. What they're really doing and kind of what they really brought is computers that are able to vote with computational power. In a proof of stake system like Ethereum, for example, they vote with monetary wealth, and so that voting mechanism, that consensus mechanism, is important to build trust in the network. That's how you trust who is legitimate and who is not legitimate, right? Now, because of the fact that Bitcoin created a market that was precise in what it needed, which is really the validation of transactions, we are arguing that we can use the exact same mechanism of markets specifically, to decentralize AI, right? So using markets to decentralize AI in itself gives us the power to tap into Bitcoin, Bitcoin's compute in that sense. And at the same time, we end up with the power of a global hive mind in a borderless decentralized system. So what we end up with is really a massive interconnected neural network in a sense, because you're kind of stitching the inputs of one network to the outputs of another. Sorry, the output of one network to the inputs of another, and you're kind of creating this gigantic hive mind of knowledge that's compounding over time. So in an ideal world, what would happen is you would end up with TAO being the actual representation of knowledge in itself, right? This what we're really arguing for is that it's not the knowledge or the wealth of knowledge is not in data. It's coming from the insight we gain from data using neural networks, which is what we're tying TAO to in the first place.
Right. You mentioned a good point here. If there are only 4,096 miners, and help me understand here. So each node represents a person or a group training or kind of running a model, right? And does that mean this network is limited to only 4,096 people around the world, like groups around the world? Because as AI grows, I'm sure many people would want to participate in the network. So in theory, how does Bittensor network grow in size? And also, how do you keep track of it?
Yeah. So we capped 4,096 ourselves. We're not allowing more than 4,096 to join just because we are scientists and we're trying to solve this experiment first in a controlled environment. So we want to make sure that this works at 4,096. This consensus mechanism that we built, this validation mechanism that we built, these models we're actually able to build something close to or at or even beat state of the art at 4,096 nodes, right? Now, For example, everyone in the network right now is running some form of GPT or something downloaded from Hugging Face. If you count all of their parameters on a conservative estimate, it's at 500 billion parameters kind of collectively. More liberal estimates from folks who are a little more bullish about it are saying 3 trillion, which is crazy, which we don't think is true. But it's still a nascent network, and we want to be able to validate it first. So that's why we kept it at 4,096. Now, eventually, this number is going to grow. We're going to double it, triple it in size, go to 10,000, 20,000, 100,000. But until that point is reached, where we're comfortable and we're confident to say that this algorithm works, we want to kind of keep it there for now.
Got it. Okay, so that's a really good way to understand it, because it's basically you want to prove out that this works, but it's not like capped, as opposed to like Tau, for example, 21 million. It's a hard cap. It's not going above. But this is basically you want to test it out and then grow.
So, sorry, just to clarify this a little bit. So Tau 20 million is not in circulation right now. That's 20 million in total, fully diluted. So that means maybe I think it's in 2148, the year 2148 is when the 21 millionth Tau is going to get mined. But and that's because we follow halving events and the same inflation curve as Bitcoin. So for now, I think there's only 2 million something that's been down.
Yeah. Right. That's right. Mm-hmm. Okay, cool. So now today, coming back, what is the incentive for someone to join the network? Meaning, like, for example, let's say I have a really powerful GPU. I'm a really good miner. Like, why would I want to join and help out like lesser or low performing miners? Like, what's the, also for the average person, what's the incentive to join the network?
Yeah, so it really depends on, it's like you said, there's the average person and then you have the AI expert or the AI researcher, right? Both of them have different incentives to join the network. Now, for the average person, let's say the average crypto enthusiast that would be interested in this would probably be, to be honest with you, mining is a lot of fun. But B, and more importantly, it's they will be able to earn back some of the, actually, if not more, than the compute that they've already spent on this, right? So, for example, your average person is, let's say, a Bitcoin miner running a Bitcoin mining rig and is spending some kind of X amount of hash to actually, spending goodness knows how much on electricity just to kind of be able to mine this coin. Tau A is smaller, doesn't require as much. B, it's easier on GPUs. And C, it's you obtain, you're kind of able to earn back what it is that you spent if you want to invest in this project in the first place on the price of Tau itself as it grows. I can't speculate on the price, to be honest, but that price is out there if people want to look it up. We think that the more important person to influence and the more important people to join are going to be the AI folks. They are the folks who are going to drive this project. The normal person will contribute to GPU, and that's great. That's going to be very useful for everyone else. But the AI folks are going to be the ones who are going to bring the diversity that we need to the project. They're the ones who are going to be able to come up with new and interesting architectures that are going to be maybe something we haven't seen before, right? That is more compatible with the Bittensor network than what exists today, which is really our API plugin to Hugging Face, which is what everybody's kind of downloading a pre-trained model, and that's what it's running. So because of that, there's a lot of supply in Bittensor, and we're still kind of working on the demand bit as of this point because the project's so new. So the AI person's incentive here would be the quality, right? So the quality of the logics and the embeddings they're getting back from the network to train their model, we believe that's going to be where we're going to really shine, because you're getting a lot of diversity out there.
Right. No, that's great to understand. And in terms of governance, right? Mm-hmm. So one, how will this network be administered, governed? Because, and I'm thinking of how a DAO is governed, for example, and there are mechanisms to do that. So in this case, how are you thinking about governance?
Yeah, it's a good question. We're just now starting to think about that. For the time being, the network's been entirely handled by the foundation, the Open Tensor Foundation, which is myself and Jacob and all of our team. And we're the ones who are kind of making sure that it's guided in the right direction and growing it out as it should be. In the future, we don't want that level of control because we don't believe that it should reside with one company or one entity, really, because then otherwise, how are we any different from corporate or corporate AI? What we really want, as you mentioned, is something similar to a DAO. I don't like that word, to be honest with you, because it's tied with so many bad connotations, but effectively, we're exploring something like a locking mechanism of Tau. So one way you could do it is if you have some Tau on you and you wish to kind of participate in these decisions that we make, you can effectively stake it to one of the foundation validators in exchange for voting rights. So what happens is you earn some dividends on that Tau. We keep a percentage just to kind of keep the foundation running. and you earn back the majority of that. And in exchange, you also get voting rights. So you can basically vote on these changes that we make. Now, one of the big differences between us and like a Bitcoin network, right? So the Bitcoin network itself is it's a network running, and that's it. That's all there is to it. There's no crazy changes here. The Bittensor network, because it's effectively decentralized AI network, there's a lot of hyperparameters that we're always tuning. Everything from batch sizes to sequence lengths to really capping the distance between minimum and maximum rankings and so on. Really a lot of knobs to turn to keep the network running. So it's more like a ship than it is like a boat, right? Bitcoin network is just a rowboat and you're good to go. Not to say anything bad, but like that's kind of how they function. Whereas for us, we're more like a ship with a lot of like turns and knobs and wheels, and you have to kind of make sure everything is running exactly right. Otherwise, you're kind of messing up the consensus mechanism, and the wrong people are being rewarded, which is a problem. So right now, these changes are made by us all the time. We're the ones who are announcing these changes and then to the community and then changing them. But in a more idealized setting is we want the community to be able to vote on these changes, right? The community will say, okay, this is a community of AI engineers. They're all running this. They all have some tau that's staked and that's like locked in with the Open Tensor Foundation, and they have a vote in how big to make the batch sizes from here on out, right? Should make them bigger or should make them smaller, and so on.
Right. Actually, that's a really good way of giving people a chance to participate, and yeah, it's proportional to the value you've created. Meaning, if you are a more prominent member of the network, more rewards, take it, and you get voting rights, and obviously you get to influence where this network is going. And obviously, if you want the tau back, yeah, take it, but you lose voting power. So I think it's a good balanced way of getting people involved, and I absolutely agree that it shouldn't stay with just you and Jacob in the long haul. Okay, one final question before we move into the rapid fire round. Where will Bittensor be in 24 months? Meaning, if you're talking in 24 months, what would have happened, and where do you see Bittensor going?
Good question. There's a few things that I would love to see for Bittensor in 24 months. The first thing is conquering the problem for text-based analysis. So we want to be able to say confidently that this consensus mechanism works. We've created a model that is close to state-of-the-art or at state-of-the-art or better than state-of-the-art in text generation or in text analysis or just based a text model. Third, I'd love to see us move into other modalities by that point. We're looking to do that ideally by next year, but by that point, we want to expand even further. So one of the concepts we're working on right now is subnetworks. So you can have, within the same blockchain itself, you can have a subnetwork for validating text, subnetwork for validating image-based models, subnetwork for validating audio, and so on. That bit of engineering is rather complicated, but we're looking to ideally have that done in the next little while so that we can actually kind of deploy that. If that's kind of deployed and ready to go, we're in really good shape to kind of start validating different modalities. A more kind of extension of that is multimodal models, right? So things like the stable diffusion models or the dall-es that are out there. We'd love to be able to deploy those on Bittensor as well and kind of train them and make them even more powerful. And finally, of course, I'm sure with a lot of community folks that are waiting for it is the decentralization of tau, which is being able to be listed on exchange legally and kind of move on from there.
Right. Amazing. I think this is, first of all, personally as an AI practitioner, I'm excited by this, and I think it's a really good concept, especially unless where we are right now is unless you're Google or OpenAI, you cannot really build a giant model because just the sheer amount of resources you would need, it's crazy. So I want to participate, but there's no resources. I think it solves a really important problem, and I think you're right. If you connect enough number of nodes, the network will be more powerful than many supercomputers around the world. So I think it's exciting, and obviously it has to work in practice. So fingers crossed on that. But it's certainly very exciting. All right. With that, we are at the rapid fire round. I'm going to ask a series of questions and would love to hear your answers. You ready?
Yeah, sure thing. Good to go.
Question number 1. What's your favorite book?
Count of Monte Cristo.
Wow.
Favorite book. Really good book. Yeah.
Yeah, it's a long read, but it's a good book. All right, next question. What tool do you end up using the most for your work today?
Are you talking about programming or are you talking about just generally speaking?
Actually, let's do both.
Yeah, huge fan of Visual Studio. I use that very, very often. The amount of plugins I have installed in my Visual Studio, I think should charter an academic paper by itself. And then generally speaking, I'm a huge fan of, I'm trying to find the name. You know what? I'm going to go with Discord. I use Discord like almost on a daily. My co-founder and I, we actually just met for the first time this year. We've been working together since 2019. Been on a Discord call every single morning since. So yeah,
Wow.
Discord.
Amazing. All right. Next question. What has been the biggest development in AI over the last 3 years?
Oh, that's a solid question. I would have to say, just because it just lies, I was going to say Transformers, but that lies just outside of 3 years, so not quite. I'm going to have to go with really the Stable Diffusion stuff. It's so fascinating. It's so fun. And I don't know if anybody's joined, for anybody here who's joined the Midjourney Discord, join it and just play with their models. They're so fun.
Amazing. Yeah. I did Midjourney, Stable Diffusion, dall-e. It's all really fascinating, and I agree. I think this question should be change into, apart from Transformers, what is the biggest? Because I think it's such Transformers, it's so much in the zeitgeist that
it's so fundamental at this point.
Yeah, it's crazy at this point, and it is very, very big. But yeah, I think one, it's 2017, and two, I need to caveat the question. All right, next one. What's a common mistake made by early stage ML practitioners in terms of career building?
They focus far too much on the AI model itself and not enough on the data cleanup. So if you think of it in one sense, you think of your entire AI solution as a car, right? Your AI system is like, or your model is your engine, right? Your data is your fuel. If your fuel is not good, your engine's not going to be good. So what I've actually, in my career, at least as a grad student, as a practitioner, and now, also as a founder, I found that data is honestly almost just as important as your architecture, if not more so. So you need to have clean data to get a clean results. You can't just tackle it with a fancy architecture. You got fanciest architecture in the world. If your data is bad, results can be bad.
Right. Next question. What's your favorite interview question when you are evaluating ML practitioners?
Ooh, technical or non-technical?
Let's do both, technical and non-technical.
Okay. So non-technical is usually, I love to ask, how would they do what we built differently? So what we built is open source. It's all the work is out there, all the white papers out there. We're publishing papers as well. We actually just published one to Neural IPS. And if they had read through or at least have a general idea of how we built something, I would love to hear their answer. It doesn't need to be a correct answer. I just love to see how they think about stuff. For a question that for like an interview question, really, I like to ask the classic stock question. You get an array of stocks. Tell me what the best time to buy and to sell is, and then I usually like to give them now I have to change it now that I've said it in a podcast. But I like to also give them an expansion of the question to say it's an unbounded array, right? It just keeps going. What's the best time to sell? And it's usually an optimal stopping problem in math, but nobody really ever catches that.
Actually, on the flip side, if somebody bothers enough to listen to a machine learning podcast and stay through till the end, so maybe they should get the benefit of knowing the question ahead of time.
If they sat through this, then you know what? Just let me know. Let me know you heard it. I'll let you know.
It's a little bit of a discount for sitting through the podcast. All right.
Exactly.
Final question. What's your number one advice to founders who are building out AI products?
Honestly, I'm going to tell you this because this is something I learned recently. Stay true to yourself, and whatever you think your message should be, don't follow what other people are doing. One of the things that I'm noticing is there's a lot of there seems to be, just like AI and in tech, there's trends, right? Trends in marketing, trends in messaging, trends in everything. The latest trend is, interestingly, the we are a big family trend, right? Which is, it's a great, don't get me wrong, it's a great trend, and it's a really nice feeling to feel that. But if that's not what you want to portray, don't fake it. Don't portray it, basically. If you want to portray a different message, be professional. Be professional. That's completely fine. Don't succumb to peer pressure in industry.
Yeah, I think that's an astute observation, because many times what happens is, if you're not that person, it just looks disingenuous. Like, okay, I can tell you're lying or you don't mean it, but you're saying it. So it's like, it's fine. I think authenticity and obviously, if you're authentically bad, that doesn't help. So you need to have some good belief going on, but I think you should stay true to that. And it's okay to say, you know what, we are not that, but we are this, right? So I think it comes off.
I agree. Yeah. It's very hard. If somebody smells it, it's really bad to back. It looks really bad to back away from it, and it looks really bad to try to explain it too. So It's the interesting thing was, I think it was Apple, right, in the early 90s. So Apple did this, right? If you recall, Microsoft Windows like 98, 95, or like even NT was very professional. We are business, and that's all what we're going to be, right? Whereas Apple came up with the, hey, I'm a Mac, I'm a PC kind of thing, and the idea of a Mac being more lax, more laid back, and so on, sold a lot for them. It was like a really ingenious way to do it. And they were their own brand. They were authentic in who they were.
Right.
So,
absolutely. Yeah. Allah, this has been such a brilliant conversation. And I think this is the first time on this podcast, many episodes, we've discussed what decentralization looks like, and the first time we explored the topic of blockchain. So I think this is a brilliant conversation. So thanks again for coming onto the show and sharing your insights.
Thanks a lot. Thanks for having me. Really enjoyed it as well.
What a brilliant episode on how to put AI on the blockchain. It's just amazing how this works. Thanks to Allah for coming onto the show. You can visit infinitemachinelearning.com to subscribe to the podcast. Thanks again for tuning in. I'll see you soon with another amazing episode.